Which brain areas cause a generalized tonic-clonic seizure to spread? Imagine a sudden electrical storm inside the brain that quickly involves many different areas at once. That's what happens during a generalized tonic-clonic seizure, also called a grand mal seizure. These seizures usually start in a small part of the brain but then spread rapidly to involve both sides of the brain, causing the typical stiffening and jerking movements. To understand how this spread occurs, we need to look at the key brain regions involved. Most often, these seizures begin in the temporal lobes, which are located on the sides of the brain near the temples. The temporal lobes are common starting points because they are rich in nerve connections and can easily generate abnormal electrical activity. Once the seizure starts there, it quickly spreads to other parts of the brain. The thalamus, a deep brain structure that acts as a relay station, plays a major role in seizure spread. It helps synchronize activity across both hemispheres of the brain, making the seizure become generalized. When the thalamus is involved, it facilitates the rapid and widespread propagation of abnormal electrical signals. The basal ganglia, which are deep nuclei involved in controlling movement, also participate in seizure spread. They help modulate motor activity, and during a seizure, their activation contributes to the motor symptoms like stiffening and jerking. Another critical area is the brainstem, which controls vital functions like consciousness and arousal. When the brainstem regions are activated during a seizure, they impair awareness and consciousness, which is why people often lose consciousness during a tonic-clonic seizure. The brainstem also supports the bilateral spread of seizure activity, making the seizure involve both sides of the brain. The cerebellum, traditionally known for coordinating movement, shows increased blood flow during these seizures. While its exact role isn't fully understood, it may influence how seizures progress and how they stop. Finally, after the seizure begins in one focal area, the abnormal electrical activity quickly spreads to involve both hemispheres, cortical regions, especially the frontoparietal areas. This bilateral cortical involvement results in the widespread muscle contractions and loss of consciousness seen in tonic-clonic seizures. In summary, the spread of a generalized tonic-clonic seizure involves a network of brain regions. It starts in a focal area like the temporal lobe, then involves the thalamus, basal ganglia, brainstem, and both sides of the cortex. This interconnected pathway explains the complex motor symptoms and the loss of awareness during these seizures. Understanding these pathways helps doctors develop better treatments and interventions for epilepsy. Always remember, if you or someone else experiences seizures, consulting a healthcare professional is essential for proper diagnosis and management.